colleagues, what's up? Ohayo gozaimasu. Today we're going to be talking about exercise 1.2, which is all about functions. So I will not do the MCQ part and the easy ones. I will directly go to the creative questions or the word problems, which you will get from number 15 to the number 17. We will solve those in short. Hope you will all understand. Okay, now the number 15. Number 15. The question gives us a function which is f of x is equals to 2x minus 1. Okay, the 15.1 is find the values of f of x plus 1 and f of x half. Okay, we need to find the values of f of x plus 1 and f of half. Okay, let's get right to it. Okay, what is f of x plus 1? It's basically you put this value in the place of all the x's in the equation. There's only one x, that's easy for you. F of x is equals to okay, sorry, I'm sorry. It will be equal to, you just put this value in the place of x. Multiply those 2 with the ones in the brackets. There we have it. This is the value of f of x plus 1. Now what's the value of f of half? Let's check it out. F of half is equals to 2 into half minus 1 is equals to, these two cancel out each other. We got 1 minus 1 is equals to 0. That does it for the first one. Now the second one is verify whether the function f of x is 1, 1. What do we know? When does a function is 1, 1 function? When every element of a function is equals to only one value of the range. When one domain has only one range, then we can call it a 1, 1 function. Okay, now the function, the number 2. Okay, let me rewrite the function again. F of x is equals to 2x minus 1. Okay, it's 2x minus 1. Let us presume that, okay, my mistake, f of x1, x sub 1 is equals to f of x sub 2 equals to f of x sub 2. If x sub 1 is equals to x sub 2, then we can say that this function is a 1, 1 function. Okay, now, or we put the values of these, that is this, 2x sub 1 minus 1 is equals to 2x plus 2 minus 1. Add 1 to both sides, these two ones cancel out, or 2x sub 1 is equals to 2x sub 2, divide both sides by 2, therefore x sub 1 is equals to x sub 2. So we can say that f of x is 1, 1. There we have it. That is the number 15. We go to the third one of number 15. It says if f of x is equals to y, okay, it's always equals to y, determine the values of x for the three mentioned numerical values of x and draw the graph of the function. I'll leave that to you. It requires a graph, and now currently I don't have any graph at my home, so I'll leave that to you. If you face any problem, be sure to knock me out in. Okay, number 16 is the second last math of 1.2 in higher maths. Okay, the question here says that f of x is a function whose value is 3x plus 3. Another function g of x is equals to x minus 3 divided by x, and also both these functions domain and range belongs to real numbers. That means all the values which are real and defined is probably a value of it. Okay, so the first question asks us to find us that g inverse 1 of 3's value. Okay, now g of x is equals to x minus 3 divided by 3. So what is the value of g, the inverse function of g of x? Okay, now we assume that g of x is equals to y. I will not write it, but you have to write it in your exams. Okay, now I'll go directly from this line to this line. Y is equals to x minus 3 divided by 3, or 3y, or 3y is equals to x minus 3, x minus 3. So therefore x is equals to 3y plus 3. So g of inverse x is equals to 3x plus 3. If you did not understand why I put this x, it's the rule of the inverse function. If you do not understand, check out my previous videos. You will find the proper explanation of that. Okay, now what is g of inverse of 3? Okay, now put the value 3 here. So is equals to 3 multiplied by 3 plus 3 is 9 plus 3 is equals to 12. Here you got the answer of number 1. Number 16, second one. This tells us to prove that f of x is onto function. We have to prove it that it is an onto function. Okay, so the condition of being onto is well defined, but if it is onto, then it must be 1 1. So first we need to prove that f of x is 1 1, then we have to prove that it is 1 2. Okay, now let's prove by seeing that we can say that it's 1 1. Still we have to prove it. Let f of x sub 1 is equals to f of x sub 2, or put the values x sub 1 plus 3 is equals to x sub 2 plus 3. Okay, here we have another line cancelling these 3 outs and dividing by 3's. So therefore x sub 1 is equals to x sub 2. That means it is 1 1. Okay, sorry. Now we have to prove that it's onto. Okay, to be onto, we have to put the value of x, that is the inverse of this function, and if it is equals to y, then we can say that this function is onto. Okay, first we need to find the inverse of f of x. So let f of x be y. Y is equals to 3x plus 3. We put the subtract 3 from both sides. We get 3x is equals to y minus 3. Therefore x is equals to y minus 3 divided by 3. Now I say the value of x, so we do not put here y and find the inverse function and then put here with the variable x. We need to get this thing here. Okay, let's do it in the next page. Okay, the question, the function was f of x is equals to 3x plus 3, and we got the value that we got x is equals to, what was it, y minus 3 divided by x, y minus 3 divided by 3. Okay, we put the value of x here, so f of y minus 3, but you have to write this, f of y minus 3 divided by x is equals to 3 multiplied by y minus 3 divided by 3 plus 3. These 3 cancel out, is equals to y minus 3 plus 3 is equals to these 2 cancel out each other, equals to y. Therefore, we can say that f of the function f of x is on 2, since it has an inverse function. Now we have to prove that the function g is equals to the inverse of the function f. So how do we prove it? We need to figure out that what is the inverse of f, the function f. So you need to show that, like this. You need to show the inverse function. So I'll directly go to that. You just need to show that f inverse of x is equals to x minus 3 divided by 3, and then you put that the value of g of x is also equals to x minus 3 divided by 3. Therefore, we can obviously say that g is equals to f inverse. That's proved. Now the last one of the exercise 1.2. So the question gives us that f of x is a function whose value is root over x minus 4. Okay, number 1, it tells us to find the domain of the function f of x. Okay, what is the domain now? The domain is all the values that can be put in the place of x so that the value of y is defined. Okay, here's a root over. So what do we know? The negative roots have no real values, it has imaginary values. So this value right here, x plus 4, this value right here, x plus 4, must be greater than or equal to 0. This value must be greater than or equal to 0. Mind it. If there is negative 1, it's imaginary or undefined. Whatever you tell it, I tell it imaginary, because you will learn about imaginary numbers in the higher classes, which is defined with I, and i's value is root over negative 1. You will come up with it, but it's not a headache right now. Okay, so what will be the value of x? So we can easily find that you will do inequalities in the upcoming chapters, or x must be greater than or equal to positive 4. We add 4 to both sides. Okay, so x must be greater than or equal to positive 4. Therefore, we have to write in this way that dom f equals to x greater than or equal to 4, or you can say that like x must be equal to, like starting from, okay, my bad, x must be equal to third bracket 4 to infinity, up to infinity. This is the answer of number 1. The second one, it tells us to prove that f of x is a 1-1 function. Okay, let's do it. Let's do that. Let x sub 1 is equals to f of x sub 2. Put the values of x sub 1 minus 4 is equals to root over x sub 2 minus 4, or do square on both sides, x sub 1 minus 4 is equal to x sub 2 minus 4. Therefore, x sub 1 is equals to x sub 2 if we add 4 to both sides. So f of x is 1 1. You got that? Okay, now the third one requires a graph. I'll give you a hint how to do the 17 number 3 and the third one of number 15. You just do a table, put the x values starting from 0 or whatever you like, and just find out the y values and put the points on the graph and just join the points. That way you'll get the graph, and you can determine whether it's a function. If the x has only one y value, then it's a function. If it has several values of y, then it's not a function. That's it. Hope you found my video resourceful, and do like, share and subscribe to my channel. There is no limit for learning. Spread the knowledge. Arigato.